These are semi-infinite structures here. So what is the field strength at point O? Find EO. What all you have? Two semi-infinite rods and one semicircular wire or semicircular ring. So we have to calculate the field strength at point O. Well, for a rod, semi-infinite rod, what is the method I suggested you? You have to directly go back to the yesterday's discussion. Now, what is the best way of semicircular rod? Better to go for E parallel, E perpendicular, no? And what is that? Components will be G lambda by D only. Due to long wire, it will be 2G lambda by D. So let me start giving numbers. Let this be 1, 2, let it be 3. No, due to 1, there'll be perpendicular component. E1 perpendicular and E1 parallel like this. E2 perpendicular and E2 parallel. I agree this. This distance is 2r. Okay, let me write it here. Now check it here. Now due to semicircular wire, it should be it should be in this direction. How much it should be? 2G lambda by r, or let me write E3. So E1 perpendicular. So what are the magnitudes? E1 perpendicular, E2 perpendicular, E1 parallel, what is the magnitude of all this? G lambda by D. So therefore y components will cancel out. So the net and what about E3? So other side we have E3. What is E3? Just now we have discussed, no? 2G lambda. What is the angle subtended? Pi, no? Now I think you have everything in front of you. E1 parallel plus E2 parallel. The sum of that should be equal to E3. So the net field at point 3 will be 0. Sir, how come? The mathematics is what helping us here. Or else, sir, I'll assume small element here. I'll find out first E1 bar. Then I'll assume small element E2 bar. Then I'll assume two symmetrical elements. I think what we did earlier, that only the conclusion is what we should apply. Not like every problem, you should assume a small element and you do mathematics. Already we derived it. That formulas is what you should take help. Please do understand the methodology here. For different shaped objects, already you know it. Semi-infinite rod, semicircular wire. Then apply that formulas and conclude the answer. So the net field at point O will be 0, that one.